Welcome to a new test and teardown video. This time it's a Philips sine wave generator called GM2307. It is from about 1947 to 1951, depending on where I look this up. It is, of course, fully tube based. We'll find 5 tubes in here, and most of them there are dual purpose, some dual triodes and pentode triodes and stuff like that. And the main idea with this oscillator here is we got actually 2 oscillators and a mixer. And one oscillator here, the readout scale goes from 0 to 15 kilocycles, but that is of course not the real frequency of this oscillator, but it's mixed together with another oscillator that is running at a much higher frequency, and the variation of this oscillator is 0 to 1000, and that is of course the output frequency. So the idea is both of these oscillators, you set the 2 dials to 0 and 0, and then you adjust here. This is an adjustment for, I don't know exactly which one of them, but you adjust to 0, and then you have a 0 beat indicator here, and now it is calibrated for operation. It will, of course, drift with temperature and all that kind of stuff. This is, tube and capacitors and whatnot, right? And then it should go fairly accurate from there. You mix the 2 outputs, and then you get one single output that is a mix of these 2 oscillators. We got some different output configurations, where we have a direct output and we have the attenuated output. And we have, of course, variable output and how much is the impedance and all that kind of stuff. So one more little funny thing is those 2 banana plugs down here, that should actually be the ground, but here it says direct output and it looks like this is the output, but that is not the case, because if I measure ohm between these 2, there is no connection. So what the heck? I found a Dutch manual from about 1947, and in that one it says that this one is 12 kilos and it should use about 40 watts. But I think my model here is a little bit older, because at the back here it says 50 watts. See, this one was modified. This is not the original power connector. And I can't really see the selected voltage, so we also need to have a little look at that. Here is my serial number and the 50 watts. And this is a classic Philips grounding screw. So I'm still trying to open this darn thing, and the manual actually says how to open it, because as you can see here, this cabinet is one solid piece of metal. So the idea is you need to unscrew all the knobs, and then you got some screws here in the back, and then you can pull out the entire unit. Of course, I removed the back plate, but the knobs, they are made with iron screws, and due to moisture and stuff, you can see those are also iron shafts, and they corroded as well. And I give up now. I've just broken 2 screwdrivers trying to get this one and that one out. I was only able to get 3 out. So there's no way I am able to get the knobs away without breaking them. And luckily I didn't move the screws or anything like that, because you can still feel that everything here is perfectly fine. So I'll have to put on those 3 again, and then hopefully the unit will work. I don't know. But we can at least see some of the wonderful parts inside. And there is a little label down here that says about the different tubes we got in this one. We got 6 tubes. So one is a voltage regulator. That one here up to the right. Those normally don't count in the tube list of Radio Museum and some other sites. They only talk about like real tubes, but we got 6 in here. Look at that one. This is one of the more important oscillator tubes, and look at the big thick piece of steel around here, making it really stable. I mean, so this is a shield and with tons of weight to it, stabilizing this area. I have never seen this thickness before around a tube. So we got 2 oscillators, and the 2 we got some inductors, resonators in here with trimmer capacitors. We can't really see a lot. And down here we got the variable capacitor. Here we go. This one is connected to the front panel. And over here is the other oscillator. And again, the trimmer capacitor. And a lot of trimmers down there as well. It's quite beautiful. I'm just so sad we can't see the rest of all the parts that's hanging all over the place here. And the voltage regulator tube, oh, that is one beauty. Oh, and the magic eye is down there. This is the very rare EFM1. Oh, can we get some light in here so we can see? This is a really big socket. Nice magic eye. And the EBL21 here. This is the EC2 rectifier tube. They are a little bit dirty. I tried to clean as much as I could, because normally I want to wash away this kind of dirt here, because this smells real bad when the tubes, they go really warm. This tube here was halfway out the socket when I got it, so that was really good. I opened and inspected. I can't really see if any of the capacitors, they are leaking or anything like that, because I can't really get in there. So this is so annoying, and I don't want to break the knobs. So maybe I have to if it's not working, but we will definitely have to see. So here's what I've done. Connected the output to my scope and a little extra ground wire, and now let's try and see what happens if I power it up real slow. It goes on immediately, and I didn't even find any on-off switch here at the front. Maybe I'm just... Where is that? So that is what is that? 50 volts, and it's using 3 watts, so it's not using a lot yet. But of course we need to have some warm filaments. So this is 100 volts and it's using 5 watts. So I feel we can go up 150. Yeah, that is nearly 200. Oh, now it's 220 and it starts using a lot of power. That is 230 and it's using 45 watts. We are very close to nominal power usage, and look at that, we got a little bit of light in this indicator right here. It is very dim. That is not what I expected. Because if I put this to 0 and this to 0, I should be able, and I don't see anything on my scope attenuator. Oh, look at that. Ooh. Can you hear this? I can hear some tones. I don't know what is going on at the moment. What I see here is more or less just hum. So this is just mains frequency. So what have I done wrong? This down here should be ground. Maybe try and move it up to this one. And I get exactly 50 Hertz. Oh, why am I so unlucky? Okay, look at that. So we got a lot of AC mains output. That tells me we got some disconnected capacitors, rectifiers that were not working or something like that. It's running on, it's more or less AC. But look at that. If I'm turning the adjustment, this one, and I dialed both of the frequency dials down to 0. Now I should 0 beat the output. Look at that. Get a little bit here. That is the high frequency you need to look at. And then I go down again. See? Low frequency. And then it's almost gone. So now I can dial this one to, for example, 1 kilohertz. And there you have it. This high frequency AC you see here is probably 1 kilohertz. And if I take the other one and dial this up to this one, dial this up to, oh, look at that. Now I get higher frequency. So this tells me the two oscillators actually work. This magic eye is very, very dim and it's not responding to anything at all. It's also not responding to anything like that. And there's this output here is nothing is working, this output, and this is my direct output, and this is the 50 volt output to just see anything at all. So, and here's the amplitude control. I mean, this unit is completely dead, and it really bothers me that I cannot pull the knobs off and get into it and repair it. Oh man, I am so sad about this and frustrated. What can we do about this? I haven't given up completely to get in here because this unit is not working and the capacitors are completely off, or the rectifier's defect or something like that, because we got mains hum all over the place. Or maybe it's this switch that sets the auto output asymmetric, or I mean there's something with grounding and all that kind of stuff in that one. But we definitely got some problems with the mains frequencies all over the place. So I need to get in here. So now I filled up all the knobs with this fantastic VD40 because they says ooh.
You needed to buy more screws.
Yeah, I broke 2 screwdrivers, so
that was bad.
That was bad. So that was one of the biggest knob removement fights I have had in a long, long time. And you can probably even see here on the shafts how corroded they are. And this one was really, really bad with the corrosion and all that. But I managed to get them off, and I cracked one, and there's another one where I can't remember which one it is, where the thread is, or the screw is broken and I'm not gonna get it out. So, but that is another quest for later. Now I can get the content out and start my real job to see if I can get it working. We got even some hidden screws under here and under here. See those 4 screws as well. A little hidden trick. So inside this beautiful unit, I am still trying to figure out what is what and where is everything located, because there is of course no we got circuit diagrams and all that, but there is no circuit boards as you know it from more modern equipment. So everything is just mounted like that, flying leads or point-to-point construction. But in the manual they put in a lot of nice pictures to show exactly where is everything located. I should definitely try and put in some pictures from the manual, and it is so beautiful the way they have made those drawings. The most important, that will be the C39 capacitor for the high voltage. I took out the tubes to inspect the sockets and to clean the sockets and to see that everything is nice and fine. We can see the 2 oscillators. So B3 is the 100 to 115 oscillator. So this is kilohertz, and they're using this beautiful red tube here. I should of course show the circuit diagram so you will see what's going on here with this oscillator. And then there's another oscillator, also a variable oscillator, and it's right here. So you see down here is the capacitor, and this one is using the ECH42. So this is a little dual tube, and that is why you can make an oscillator and a mixer all together in this little one tube. And up here we got the voltage regulator, 150 volt, and this one is for this tube over here. For its anode supply is running at this 150 volts, while everything else just runs on rectified and filtered mains. And that will be the output power pentode driving the output transformer. This one is the filter choke between the capacitor system here. We got C37 and C38 in the high voltage system. And the reason why I write all these numbers here is that I think there's something wrong with the anode supply, and that is why I want to debug that. I also, while I was taking this apart, I found a lot of loose nuts and screws, and also some of the screws here and the nuts around the banana plugs, they were loose. So maybe that is what's causing the output to not work. I really need to inspect a little bit more. We can see some really dark marks on the magic eye. So this maybe explain why it is so dim. By the way, the magic eye is also used as one of the amplifier tubes in this construction, not just for indication, but also doing the pre-amplifier before the output stage. And here we can see the 2 oscillator adjustments. And we got components on a lot of different sides here, also in this little extra compartment between the top and the bottom part. And you can unscrew everything here and fold this open I hope I don't need to do that because we've got some wires going between them, and I think it's a little bit of a problem to get in there. During my inspection rounds of this unit, I found all sorts of problems with those different connections to chassis. That will be my ground outputs, of course, being loose. And here is the anode capacitor. That wire here was just almost touching. This is the ground. I mean, why don't you make stuff here? This one is of course isolated, but I mean, and that is two quite interesting capacitors. I think they adjust the two oscillators so they match perfectly when you set them to 0 and 0. Of course they are not 0 in real life, but the result of your mixer needs to be 0. And then there is of course this one. Yeah, here we can see the oscillator. Oh yeah, it actually goes faster and slower the higher the output is. Isn't that interesting? And how about this one? This one goes the other way around. So the lower the number, more capacitance. That means lower frequency. So that is very interesting about the way the two oscillators work and the way you get the mixed result. So I was able to find some of the missing connections. Oh, look at the voltage regulator, how beautiful it shines. So I'm measuring the DC voltage at the, what is that called? C39. And we got 228 volts, but we got no AC. And yes, it is connected to that point. So now I can see AC and DC at the same time with 2 meters. That's pretty nice. And this is a good idea when I'm dialing around here with this. This is the drive to the Magic Eye and to the output amplifier, that one. See, when I touch this one, I see some AC. And you also see that on the output. See, it goes like that. So the noise from the potentiometer definitely is amplified. So that tells me a little bit about what is actually working and what is not working. You can see there's a nice bandwidth when I dial this around, and we have no response whatsoever on the two oscillators. Nothing happens on the output. That was good news. Somebody's been poking around with things they don't know what they're doing. And this is also a thing that I see all the time, by the way. So this is the oscillator tube for the narrow band adjustment, right? And we got some capacitors here in the feedback system, and they need to be right for this thing to be oscillating. And here is 101 more or less. If I touch the dial, see, this is all the way to one side, 101.1, and if I put it all the way to the other side, it's 102.2. So that's 1 kilohertz. Here's another fun thing about poking around with tubes, by the way. They run warm, right? So here is the oscillator that is working. Look how beautiful that is. And this is only with a thermal camera. So let's just pretend we're real dumb and don't know anything about anything, right? We can just look with a thermal camera, look at the tubes, and they're all nice and shiny here on the thermal camera. And here is an oscillator that is not working. So, oh dear, look at that. That tube, you can probably even, we can maybe just see the shadow of it. There is no heat. So from the previous picture of a ice cold tube, you could definitely imagine this tube is defective. But on the 2 pins right here, pin 1 and pin 8, that will be the filament voltage. Those two right there, they are the pins on each side of the little locking pin, because this is called a RimLock tube, so it's so easy always to find 1 and 8, the filament. So let's take the tube and also try and give this 6.3 volts. Ooh, now it's nice and warm. How is that possible? So, maybe the socket is broken. How annoying is that? Because I don't have any RimLock sockets. So now I will try and see if I can fix the pins in the socket. Damn. And there you have it. Now this tube is also oscillating, and this is the much wider span oscillator. So let me grab this one and see. 84 to 100 kilohertz. So I was expecting this one to go to 101 exactly, the frequency where the other one stops. But I will of course need to do a little bit of calibration and all that kind of stuff. But now it is oscillating and I'm super excited. Let's try and see what happens to the output. And what do you know? This is the output. And if I play around with the... So this is all the way down on one of them and then the other one. Ooh. We can go down to 400 hertz. Of course, this is a little bit of an adjustment we need to do. And by the way, the ripple you can see here, that is causing a little bit of annoyance. Like that. It has all something to do with this tube and its bad socket. Let me try and see if I can show. Here is the tube, and now I'll poke around with one finger here. And now you see on the scope at the same time. See? Ooh, that socket. See? Now it's not connected. So it's... And this is definitely a really annoying RimLock socket. And I took the tube and I cleaned the pins as much as I could. And there's just no way I can fix this. And it seems to be just that tube and just that socket. How annoying is this? But at least I know exactly what is the problem. So that is something good, isn't it? Oh yeah, by the way, the last little hum here, there's this DC balance, this one. Let me see, here's my finger. Follow finger, potentiometer here. So let's try and touch this potentiometer here with a screwdriver and look at the hum. It's like, ooh, did you see that? Completely silent. And that is because of the AC balance feedback point to the input of the Magic Eye. This is the sum amplifier tube as well. And then there is this variable AC feedback point where you can null out all the ripple. Isn't that just beautiful? Let's talk a little bit about the schematic. This is the schematic from the manual. I took the liberty to draw it a little bit more nice and beautiful, so it's easier to see what is going on. So here the big fat ground line is made more visible, and I added some red on the anode supply. We can see at the bottom left, this is where we have the high voltage power supply. There is this B6 tube, and this is a 150 volt neon regulator, and that one supplies B3 tube, and that is one of the two oscillators. If you follow this wire the power high voltage to B3, you will see there is no local resistors in the anode system. There is only the series resistor to the B6 regulator tube, and that is already biasing B6 all the time to 150 volts. Also, if you see B3 tube is a pentode, it is coupled into triode mode. So this means fully on the two steering grids there are to anode voltage and to cathode voltage. So this turns on the tube completely. R30 is a 1 mega ohm resistor to ground. So again, you turn the tube on completely. Full maximum potential current goes through this transformer. And this transformer to the left, where we have the anode, is also coupled to a resonance system with a lot of variable capacitors and trimmer capacitors and all that into this grid. And this is, of course, why you have a self-oscillating oscillator. And two of those capacitors in the feedback system here, they were just completely wrong. Maybe also a bad connection in the tube or something like that, but that is why this tube was not oscillating as stable. In the top left corner, we have a B2. That is the fantastic double tube, the ECH42. And that is the little RimLock tube. We have a completely defective socket. And the input to the left, that is just a filter that matches one tube to another one. To the right of B2, we have the oscillator system going on. And that is also running in the 100 kilohertz range. So the two oscillators at about 100 kilohertz, they are mixed together inside a B2 because the two of the grids, they are shared. And this is why you have the sum and the difference out on the anode from that B2. And that output from B2 goes via this filter that removes the 100 kilohertz and take out only the 30 kilohertz to the 15 kilohertz range, the audio range we need. Then we have something very interesting. To the right of that filter, you see C25. Under C25, we have two resistors. One is the variable output potentiometer, but to the left of that, we have a resistor that goes down to the power supply, where we have a potentiometer that can set the AC hum balance. So it's a positive or negative sine wave that is mixed additive into the output of our wanted signal. And by turning this, tuning this trimmer, I showed this on an earlier clip, you can completely remove hum from this system, and you only have the wanted audio. I really think it is interesting to see this wanted audio range now goes via the Magic Eye B1 tube. And so it's also working as an indicator, but also as a pre-amplifier. And our output stage amplifier, the B4 tube, is this big, powerful pentode EBL21. And it drives a very large output transformer T2. In fact, it's bigger than the mains power supply transformer. And so that is, of course, needed to have such a big transformer, because it can go very, very low in frequency. Here we got some of the really, really cool drawings from the manual. I think they're definitely worth sharing with everybody here. There's just everything is hand drawn, trying to explain where are all the different parts and where are all the connections and what goes where and so on. Don't you just think this is fantastic? Thank you very much for watching. That was all for now. Bye bye.